Remember early on we looked at factoring numbers, and we saw what that means is to find factors, namely numbers, which will multiply to give the original number. And usually in doing this we will be interested in finding the prime factors. Now, factors which contain variables are also considered prime if we cannot break them down any further. And so we're going to look at factoring of polynomials now. A polynomial has a common factor if each term has that factor. And this is the first thing that we should look for when factoring a polynomial. There may be other ways to factor, but the common factor is the first thing that we should look for. So we'll start with a simple example, 6x plus 4. And we can see that because both of these numbers here are even, that the polynomial has 2 as a common factor. Okay, so then the next step is to write that number 2, and then a set of parentheses, and then inside the parentheses we write those factors that remain after the 2 is pulled out. So from the 6x we get 3x because 2 times 3x is 6x, and from the 4 we get 2 because 2 times 2 is 4. So then this is the factored form of the original polynomial. Okay, here's one a little more complicated. 10x squared plus 5xy plus 20xy squared. If we look at the numerical coefficients, we see that 5 is a common factor in each of these terms. But this is not the only common factor. We see that x is also present in each one of the 3 terms. And so therefore 5x is the greatest common factor. And once we identify that greatest common factor, then we write it down, and then a set of parentheses, and inside the parentheses we write the factors that remain once 5x is pulled out. So from the 10x squared we have 2x remaining because 2x times 5x is 10x squared. And from the 5xy, what do we have remaining? Well, just y. And from 20xy squared, what do we have? 4y squared, because 5x times 4y squared is 20xy squared. So this is the factored form of that polynomial. Okay, next example, we have 6x squared y plus 10xy squared plus 8xy. In this case, we see that 2 is going to be common. We also have an x that's present in each of the 3 terms, and y. So that means that our greatest common factor in this case is going to be 2xy. When we pull that out, what do we have remaining? Well, 3x from this term, 5y from this term, and just 4 from the last term. So this is the factored form for that polynomial. Okay, one more example. 3x squared plus x. This looks pretty easy. Greatest common factor is just x this time. So we pull it out, And what remains? Well, from the first term, 3x remains. What remains from the second term? Well, if you didn't know any better, you would say that nothing remains. But we can't write nothing, because then if we multiply nothing by x, we get nothing. So what remains when we pull out all of the factors as a common factor is not nothing, but 1. And we must have something left to multiply the greatest common factor by in order to get what we started. In this case, we started with x, so in order to get x by multiplying x by something, that something has to be 1. Can't be nothing. Okay, so we write an x, and then inside the parentheses, we need to have 3x plus 1, not 3x plus nothing. And just a reminder that the answer in any factoring problem can be checked easily by applying the distributive law and multiplying it back out. You must get what you started with, otherwise there must be a mistake.